This section is to introduce you to color. And let's see if I can start again. This section will introduce you to color. So this section will introduce you to color. So the color spectrum. We can only see reflected light. So something can emit light, and when we see an object, it's because the light hits this object and reflects back to our eyeball. Isaac Newton was the first person to take a prism, take a small beam of light. He was in a darkened room at Cambridge, and looking at that light, he saw the colors of the rainbow. Those colors are your Roy G. Biv. These wavelengths are in nanometers. So that's 700 nanometers for red light and about 400 nanometers for your violet light. So what is black? When we're talking black light, which we are right now, it's the absence of color. It's the absence of light. What is white? Again, we are focusing on white light. It's when all the colors are combined. So if you have blue with green as well as red, you'll get white light. Additive colors. Additive colors are when red, green, and blue are overlapped. By varying the intensities of these three colors, we can perceive, I believe it's around 30,000 different colors and shades. This color is when you have equal parts of red and blue. Red plus blue gives you the color magenta. Again, we are just talking about light right now. So if we overlap the two, we get magenta. If you notice the background here, I overlapped equal parts of green and blue, and that's called cyan. If we overlap equal parts of red and green, we call that yellow. When you add all three of those colors together, we get white light. Now filters. Filters absorb light and they transmit light discriminately. Filters will transmit the color that they are. So if you have white light shining on a filter, and I depict that by red, green, and blue, so you can label those if you wish, and a red filter will only allow through red light. So here you're going to see red. Your eyeball would be on this side of the filter looking. The green and the blue are absorbed by the filter, so the filter absorbs light selectively. That was the word I was looking for. The filter actually gets a little bit warm because it's absorbing those two wavelengths. If we take a filter that is green, and we have white light shining on it, so we have red, and we have green, and we have blue. A green filter will only transmit green light, and the red and the blue are absorbed, and you see green. Again, your eyeball's on this side looking. Here we have a blue filter, and again we're going to have white light shining on it, so red, green, blue. We have a perfect filter. It transmits blue completely, and the red and the green are completely absorbed. And you're going to see blue. Again, here's your eyeball. Let's look at this situation. We have a yellow filter. We shine white light on it. Think about yellow and which two colors comprise yellow. Remember, we could get yellow with red and green. So a yellow filter will absorb the blue and transmit the red and the green, and you're going to see yellow light. What happens if you put a cyan filter there? Which two colors make up cyan? Green and blue. Now there is no blue, so only the green is going to get through this filter, and you're going to see green in this situation. Pigments. Pigments reflect the color that they are. So if we have a red pigment, it has a molecule that absorbs all the colors except red. So we have red light coming in, we have green light coming in, and we have blue light coming in. So we just have white light. The only color that is reflected is red, and that's why you see red. The other two colors are absorbed. Blue. Oops, I guess I gotta draw it in. So I have red light coming in, I have green light. Let's see if I can get green. Let's make it a bright green like that. There's my green light, and there's my blue light. It's a blue pigment. It only reflects the color that it is, and you're going to see blue. The green and red are absorbed. Let's look at, oops, come back, my green pigment. This time we have green light coming in, we have red light coming in, and there's our blue light. Red and blue will be absorbed, and only green will be reflected, and you're going to see green. When we print, now if you look at your color cartridge on your printer, you're going to see that there's three colors to it: cyan, magenta, and yellow. These are the three inks that are pre-made and packed into your printing cartridge. We usually have a cartridge of black as well, because it's less expensive to have them all mixed together, them being cyan, magenta, and yellow inks, so that we have a black ink. Those colors will give us, we're going to look at the primary colors of blue, red, and green. If we mix cyan and magenta, it gives us blue. And here's how you can think of it. We know that cyan is made of green and blue. Magenta is red plus blue. When you look at them, they both have blue in common, and so you're going to see blue. Let me go go back to this. So what happens is when you lay down ink, that's cyan. Let's see if I can make my own cyan. Here's how we can make our own cyan. Let's make it a keyboard. 125 green, and if you mess around with your colors, we'll make it 130 blue, so it's not perfect. And I don't really like that. Let's move it up a little bit more. And we'll call that about cyan. And so let me get my custom color. All right, so if we lay down cyan and then we lay down a layer of magenta, I'm going to make magenta kind of like that. Sorry, it should be purple, huh? Let's go there. Not quite magenta, but we lay down magenta. So what happens, the green comes in, gets absorbed by the magenta, and can't get back out. Your red gets absorbed by the cyan and doesn't come back to your eye. The blue is reflected by the magenta, and it's reflected by the cyan. So you're going to see blue. So we subtract out the two colors that are not in common in the inks. Let's look at magenta and yellow. So magenta, again, is red plus blue. Yellow is red plus green. Notice they have, oops, I made a mistake over here, red in common, and that's why we see red. The blue is absorbed by the yellow, and the green is absorbed by the magenta. This is how your color printer works at home. Yellow and cyan. Remember, yellow is red plus green. Cyan is green plus blue. This time we have green in common, and so you're going to print the color green when you overlap cyan and yellow. Now with black ink, if you look at it, has all three of the additive colors. It has cyan, it has yellow, and it has magenta. They make it for us because it's cheaper for them, being the manufacturer, to make black ink. Because if you want to print black with a colored cartridge, you're going to be using your cyan ink, yellow ink, and magenta. And so you're going to run out of your expensive inks quite quickly. If you take your black ink and separate it, you'll see that your black ink will separate into all three of those colors, and every manufacturer has their own special mix that they like. So there's your introduction to color.